Okay, so our next video is looking at arithmetic series. So we're still in sort of the arithmetic type here, but now looking at a series. And so if you look down here, you can see the difference now in a series is it's the sum of the terms in a sequence. So we're adding them up. So in a sequence, I'd have 1, comma 2, comma 3, comma 4, and so on. It's a list. Whereas a series, 1 plus 2 plus 3 plus 4, and so on, is a sum. Okay, so that's the thing I want to maybe write down in my notes and just keep track of. What do these words actually mean? And there you have it. Okay, all right, so next, this example is sort of a classic arithmetic series, and it says the mathematician Carl Friedrich Gauss performed this calculation at the age of 10. Can you see a quick way to do this? And so what Gauss saw at the age of 10, which is pretty impressive, not sure I would have seen this at the age of 10, but anyway, is that if I pick the last term and the first term and I add those up, I get 101. And then if I move inwards, 99 plus 2 is also 101. And so is 98 plus 3 is also 101. And the question is, well, how many of these pairs would I have? Well, at the moment, there's 100 items, 100 terms, and I'm pairing them off, so I should have 50. So there should be 50 of these terms. And so that's what Gauss did and came up with this answer. And so down here, given this series, 6 plus 9 plus 12 plus 15, we can see that each time we're adding 3. So I know the common difference is 3 and so on. Determine the sum of 4. That's the sum of these. So I could go 6 plus 15 and 9 plus 12 are both 21. So if I add those up, I get 42, and that's the sum there. So now we're going to use the letter S to represent the sum of the terms, and we have two formulas, and this one's written down wrong. This should be Tn. So the sum in n terms in a series is that n value divided by 2, because I pair them up, times the sum of term 1 plus term n. So just make sure you write that down correctly. This is an n, not a 2. Sorry about that. So this formula I would use, so here I put the little question, when do I use this one? I use this formula when I know the first and last terms are known. And now I'm looking at the other one, and here I don't need to know the last term, but I need to know the first term and then just how many I'm adding up. So here we know the first term, and a number of terms to add up. Okay, so let's look here. Find the sum of the first 12 terms of the series 7 plus 13 plus 19 plus 25. So what I might notice first is that the common difference is 6. So I would write that down, right? 13 minus 7 is 6, or 19 minus 13, or any of those. And I want to find what is the sum of 12. And at the moment, I don't know that 12th term. So I can't really use this first formula. So I'm going to try and use the second one. So the sum of 12 terms, 12 over 2 times twice term 1 plus n minus 1, n is 12 minus 1, times the common difference, which is 6. So I'm going to do that calculation. This is going to be 6, 14 plus 11 times 6 is going to be 66. And if I do that, I get 480. All right, down here, determine the sum of the series negative 60 plus negative 51 plus negative 42 plus a bunch of other stuff plus 156. So here, this sum, I would say, well, the sum of, I don't know how many terms, but so I can't really use either formula yet because I don't know what position this is. I know this is term 1, I know this is term 2, I know this is term 3. I could also figure out the common difference by going negative 51 minus negative 60 is 9. So I know that the common difference is 9. But I need to figure out what term number this is. So what I'm going to do is hold off on this for a moment and say term n is term 1 plus n minus 1 times d. And term n is 156, negative 60, plus 9 times some unknown number. And so I'm going to add 60, divide by 9, and that's going to give me 24. So n is 25. Perfect. Now I know what n is. I've got the first term, I've got the last term, so I'm going to choose this formula here. So the sum of 25 terms is 25 over 2 times term 1 plus term n. And if I do that calculation, I got 1200. And that's my sum. Okay, so here's one similar to that for you to try. I think you should pause the video here, do a similar process, and see what you get. Okay, so again, we have to find basically what position this is in. So term n is term 1 minus 12, that's d, right? If I went 44 minus 56, that's negative 12. So that's my common difference, times n minus 1. And Tn is actually negative 316. So I'm going to solve this. I'm going to take away 56. Oops, 372. I missed the 2. And then I get that n turns out to be, and I'm running out of space, so I'm just cutting the steps here. N turns out to be 32. So then you should say that the sum of 32 is n over 2, first term plus last term of those 32, and that should give you negative 4,160. So I hope you found that. And now, lastly, we're going to look at this problem. The sum of the first two numbers, the first two terms of an arithmetic sequence is 19. The sum of the first four terms is 50. Determine the first 6 terms of the series, then find the sum of 20 terms. So we have a lot of things to do here. All right, so I know that the sum of 2 terms is 19, and the sum of 4 terms is 50. So what I might start by doing is saying that 19 is, and I'm gonna apply, just so you can see, this formula here, term 1 plus term n. So if I'm only adding up 2, 19 is 2 over 2 times term 1 plus term 2. In this case, the n is term 2. And so that tells me that 19 is t1 plus t2. And I know that term 2 is actually term 1 plus the common difference. So that tells me that 19 is actually twice term 1 plus the common difference. And now the sum of 4 would be term 1 plus term 2 plus term 3 plus term 4, right? And term 1 is term 1. This is term 1 plus the common difference. This is term 1 plus the common difference twice, and so on. Term 1 plus 3 common differences would be the last one. And so this was 50. So 50 is going to be equal to term 1, 2, 3, 4 times, plus 6 common differences. So 1, 2, 3, 4, 5, 6. And now I have a system of equations where I'm going to solve for t1 and for d. So I'm just going to multiply this by 2 and pop it over here. So 19 times 2 is 38. 2 times 2 is 4 t1 plus 2d. And then I'm going to subtract this. So 50 minus 38 is 12. T1 disappears. 6 take away 2 is 4. So I know the common difference is 3. And now I'm going to put that back into here to solve for T1. So I'm going to take away 3 and divide by 2. T1 is 8. So now I can write out my terms. So term 1's 8, add 3, add 3, add 3, add 3, add 3. And there we have it. So the last one, this problem, quite a bit trickier than the others, but certainly not beyond you now that you know how to solve a system of equations.